Thank you for staying after, rather, thank you for staying awake after lunch. But I think that was a very nice talk preceding this. So um, I'm sure none of you are tired or sleepy or having downtime in any way. Um, so my talk today is about how to secure cloud native workflows. Um, I'm sure you're a little bored of doing this already, but can I see a show of hands about how many people are using containers right now? People using containers? Okay, people who've gone from containers to Kubernetes, almost same set of hands, but little lower. Um, and are you thinking in terms of software supply chain security at all, or have you heard of the term, things like that? Good, we have a couple of hands. So I've designed this talk to be meant for audiences who are into containers a little bit at least. My demo is going to be using Kubernetes and things like that. And the meat of the talk is about software supply chain security. So if these things don't interest you, there's a couple of other tracks with amazing talks. I will not feel bad if you get up and walk away at any stage. If at any point during the talk you don't understand any of the things that you see or any of the terms that I use, please feel free to interrupt me. Otherwise, we'll probably save questions to the end. So I'll start by kicking this demo off. Um, this will hopefully run in the back. Let's talk about some stuff and then come back to the terminal because, hey, it's a tech conference and we want to see some logs, right? So a little bit of background. I am a part of the Cloud Foundry Foundation, and I got into this business of software supply chain security after Log4j shell. So I don't know how many people it affected here. It was about this time, 2 years ago. About December 20th or something like that. But it's the season. And one of the reasons I started to focus on supply chain security was it affects open source a lot. So I have been in this open source world since I started using computers in a sense. But for the past 8 or 10 years, I've been invested entirely in open source tech. And I've been working with so many different communities and engineers around the world who are just very passionate about open source, and they love what they do, and they're happy working with open source technology. And a lot of you profess to using Kubernetes and things like that. And so, and in the last talk, there was some talk about Redis and all. Again, wonderful examples of open source technology across the board that's really affecting people a lot. And so somewhere along the way, I just decided to go all in on open source and just work in that area. And like I mentioned, Log4j shell was like a wake-up call at that point in time. And software supply chain security, if you don't know the term, is this way of securing software that gets from being a part of your build, or it's a small piece that you either consume as a dependency or as a library, and you put that on, or you envelope that in other pieces of software or hardware or things like that. So let's say there's some firmware, and then you take that firmware and throw it on a router, and then you connect that router to a network, and then now that piece of firmware is sitting bang in the middle of a network. And the reason I'm interested in this area of security is because it beats your normal firewall-based network security, blah, 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 by miles. That's a very intrusive sort of attack on different networks and devices. And this is a kind of attack where you're basically permitting a piece of like malicious software to sit inside your code, your device, your network, or your servers, and you're basically allowing your infrastructure to become compromised from within. And so this is very difficult to detect. There's not enough ways in which to secure people from this. So Log4j shell was an example of that. Anybody heard of the SolarWinds attack sometime in 2020 again? Yeah, so SolarWinds was another example of this. So what happened there was a piece of compromised software made its way onto SolarWinds servers. The attacker didn't do anything for 6 months. waited until build after build after build went out on these servers. And then after about 6 months, the attacker started to slowly intrude the SolarWinds server from within and got access to a lot of customer data, got access to a lot of traffic that they're not supposed to do. So this kind of attack is extremely hard to detect. Now, somebody was asking in the previous talk, what do you do after you write code? And you gave a bunch of answers. Now, my question is, what do you do before writing code? Do you go to Stack Overflow? Yes, no, maybe. You copy some lines from there, you put it into your IDE, whatever, and then you just run it and then it magically works. So one of the favorite ways in which supply chain attackers tend to operate is they work on these forums and things like that. So there's a Docker Hub image that a lot of people use when you're doing JavaScript development called Node.js. Everybody has heard of Node.js, right? So there's another image, and it's N0DE instead of NODE. So this kind of attack is known as typo squatting. So they'll deliberately make an image that has malicious code, but they'll give it a spelling that's very close to the original. And all of us Stack Overflow, myself included, all of us Stack Overflow engineers will just go somewhere, copy something, run it, and then it'll solve a problem, and then we'll move on. But there's no way to detect how that image actually got into this code until they go back and see who's made commits, and then they'll find your wonderful git commit message, and then they'll come back to you and kick your ass. So those are the kind of very sophisticated attacks that we're talking about when it comes to securing the entire software supply chain. Nobody here is writing software from scratch. We're all using dependencies. We're all using some APIs or the other. We're all borrowing open source code from somewhere and just putting it there. And so this kind of attack really threatened to disrupt the entire open source ecosystem that I am so fond of, and I'm sure a lot of you here are too. And so that is one of the reasons that I started to pick on this theme. I started to experiment with a lot of tech that somehow helps us address some of these security concerns. And my idea here today is to educate you on some of the things that are happening in the open source world. And so I'll start with the OpenSSF. So last year, there was a new foundation that began as part of the Linux Foundation known as the OpenSSF. So it's meant to secure open source software. And so it's the Open Source Software Security Foundation, also known as the OpenSSF. And again, this is a link that you can scan and stuff to some of the ideas that they as a foundation intend to pursue. So they call it the mobilization plan. And in that mobilization plan, they have about 10 different areas where they want to focus. Obviously, I'd love to go through all of the 10 areas, but today we are going to focus on a few. So we'll focus on digital signatures. We'll focus a little bit on S-bombs, and ultimately we are going to focus on improving supply chain security. So the three questions that I would want everybody who's building software to begin with is, who is building your artifact right now? So by artifact, I mean any immutable entity that you're going to deploy to production. Now it could be a container, it could be an image inside a container, it could be jar files or I don't know who's doing Java here, but I love Java. No disregard to those people. But if you're doing like Java stuff and you put out like a war or a tar, so any binary, let's say your S-bombs, which is software bill of materials. Again, this is a concept that derives from supply chains themselves and are applied to software. And then SALSA, which is security levels for software artifacts, or supply chain security levels for software artifacts. So that's another. So again, all of the projects and tech that I'm going to talk about today are open source. The problems are because of open source, and the solutions that we are driving are also of open source nature. And so these three projects together can provide that sense of awareness about who's building it, what's being built, and where the stuff is being built. All right. So the first step I wanted to showcase was there's an open source project called Paketo, and Paketo is a family of build packs. If you've not heard the term, build packs have been around for almost a decade now, which is like a million years in the software world. But build packs basically allow you to go from code to container in one step. So if you're doing Docker build, that's not build packs, but the build packs is the equivalent of a Docker build command. So build packs will detect your source, figure out how your app and app image needs to be structured, and then create a container for you at the end. I will showcase this during the demo. It will become slightly more clear. Just be aware of some of the definitions right now. Okay. Again, this movement to SBOMs is quite predominant in the world right now, and there's also like a Kubernetes build of materials that is available. So you can scan that and take a look. You can take a look at the processes that are being described, the architectures that are being described, the protocols that are being put in place, and you can be designing a protocol instead of writing a program, and that can be an open source contribution. So again, just side note, if you're looking for ways in which to contribute to open source, but you're not a programmer, I would highly recommend looking at projects like these. That being said, what's Salsa level? So Salsa aims to incrementally make your build process secure step by step. So you can, at the start, I think everybody is by default a level 0, right? So, but then progressively, if you're able to document your build process well, if you're able to automate it using version control and a build tool, and then you're able to prove that this is the code that is exactly being built and no other dependencies, and all of the dependencies are from this repos and things like that, which is one of the definitions of provenance, then this is another step ahead. And finally, if your build succeeds and your artifacts becomes approved for deployment through a manual review and through so many security processes and passing so many unit tests that you wrote and things like that, then you have a higher level. And if you can make that a repeatable, what they call hermetic parameterless build, which means it's in an environment that nobody else has access to, and you don't pass parameters that are specific to a build, then you have one of the most secure and most sophisticated Salsa level 4 A sort of build process. So they define incremental steps that any team can take in order to take advantage of more secure builds. And finally, this is the cosign project. So this is a way to attach an identity to a container image. Now there's two very popular there are two projects that are doing this form of identity thing. One was announced at DockerCon very recently. It's called Open Pub Key. So you can try that if you're interested. Personally, I love Sigstore. Both of these are open source projects. I come at this from a more OpenSSF angle, like I mentioned. And so Sigstore is an amazing way to do digital signatures on your own infrastructure. So if you care about privacy and you want to sign builds and attest them, then the Sigstore and the Sigstore family of projects is great for that. The best way to use Sigstore is on your own private, I wouldn't say private cloud, but you can create your own sort of private identity using Sigstore. But there's also like an instance available for public good, which you can make use of, do a few test runs and workflows, and make that a more official thing by having your own Sigstore, etc. So this is the handshake that I'm showcasing. And this handshake basically allows you to go from creating your identity, exchanging a certificate, making a signature, and then verifying that signature. Again, if this seems a little complicated, it is complicated, but you'll also have a little clarity once you see what's in the demo. I've been talking about this demo, so let's actually switch to it and pray that it has run. Yes. So, in true tech conference nerd speak fashion, let's look at some logs. So the first thing that I'm doing here is I am installing a tool known as Kpack. Maybe this slide will first give you a better idea. So what I'm doing is I have a Kubernetes cluster, and this being DevFest, it is running on Google Cloud, and it will install a Kpack, which is a tool that does Kubernetes-based builds for any code that you have. I have a Node.js repo on GitHub that Kpack picks up, and then it makes use of build packs. Like I said, I'm making use of Paketo build packs, which is an implementation of the cloud native build packs, and this will build a container for me inside Kpack. Now, Kpack is also configured using service accounts to do a signature on my behalf. So it has my personal email signature and everything, and Kpack will build the container, sign it for me, and then upload it to Docker Hub. So everybody uses Docker Hub. You can replace this with your own container registry, like whatever it is, but this demo uploads to Docker Hub. Okay, so that's what is happening here basically. So the first steps you see here, hopefully this is visible at least a little bit at the back. And so after you do Kpack, this is where the build actually begins. So what happens is, Kpack receives this URL, which is a Node.js sample, and it will take a note of the Git revision as well. So Kpack is an excellent tool for Git-based ops or GitOps, whatever management marketing term you prefer. And then what it will do is it will select a bunch of these build packs, okay? And then it will create those layers. So much like Docker build packs also work in layers, and while creating layers, they generate SBOMs for every individual layer that participates in the build. Now these SBOMs will tell me exactly what dependencies were used to do the build, and also what dependencies are pulled in as part of the build for the app to use later. So these SBOMs will be generated at every stage. So if you can see here, every stage of the build generates these SBOMs. Finally, here a container image is actually created. This image is then signed. So I'm signing the build here. So the build is successful, and along with the signature, they are both uploaded to Docker Hub. Once the build is signed, I'm performing a verification here. So my public key, which I created, is verified against the signature that's available as part of the build on Docker Hub, and that will prove that the image that was built was actually built by me. The SBOMs will tell you what goes into the build. The signature will tell you who built it, and we already predetermined this Kubernetes cluster in order to determine where it was built. Now, an obvious next step is what happens when you build again. So what I'm simulating as part of this demo is a new Git revision. So I make a commit, and I trigger another build to this. And what happens is the subsequent commit will create the build again. But this time, it will take advantage of a lot of caching. So it will restore a lot of the layers. It will restore a lot of the metadata. And so what happens is these SBOMs will get restored for the next step because there's not any change. And for the one layer that changes, it will create that SBOM again, and then push this image to Docker once again, Docker Hub, and then it will sign the build and verify it for me. So basically, this part of the demo goes to show that if there are subsequent revisions and you're continuously checking in, the same workflow will get triggered, and you can continue to verify. You can download these SBOMs and view them. I will just try to do that here. Yeah, this is probably still tiny for people at the back to see, but these are all of the SBOMs. The SBOMs come in 3 formats. Like any nice technology, there's a lot of competing SBOM standards, and these are the different components of the build in this layer, and they're all verified here. Again, this is the Cyclone DX format. This is the SPDX format. It basically is the same data, but it's just stored and saved differently. So SPDX being slightly more favorable. So again, all of this will tell you exactly what's inside it and if there's any CVEs and other things that you have to be wary of. This is again based on a couple of things. So there's a cloud native security working group. There's a cloud native security tag who have a white paper published, and in that they published a reference architecture called Fresca. And I picked up Fresca. It was a little too complicated, so I did my own sort of version of Fresca, and that's this. Very quickly, where I want to take these experiments in future, this is the demo that we saw today. Where I want to take this in future is, I want to make use of, I'm not saying this because it's a Google DevFest, but there's some merit to using different container registries other than Docker Hub. I want to demonstrate that. I want to also try and make use of Kyverno for policy. So what Kyverno can do is it can continuously monitor your Kubernetes cluster in production and say, hey, I don't want this image deployed because it doesn't have an SBOM. It can say, I don't want this image deployed because it does not have a signature. So if you want a way to do compliance and policy very well, then Kyverno is a great answer for that. And I want to have this demo include that as well. And the last piece I want to include is this project called Scorecard, which can integrate to GitHub repos natively, and that scorecard can provide a metric of how secure a particular repo is. There's a lot of repos out there that are implementing OpenSSF scorecards. If you're in the business of doing that, this can be internal. You don't have to necessarily be an open project to do it. You can implement OpenSSF scorecards inside your organization, and those can be great additions too. This QR will give you details about that. Do check it out. And yeah, that was my spiel. So thank you very much for staying, for listening, everything. If you have any questions, I'm happy to take them until the next speaker sets up, I guess.
So you had mentioned about cosign, right, from Sixstore. Why can't we use something like Docker Notary, which is taking care of the whole signing process? Because it's conveniently easier for me to integrate something like Notary because I'm more into the Docker ecosystem. And even for someone who's using Containerd and all those open source approach for OCI, it's easier to integrate Notary, I guess.
I agree with you 100%. Sixstore is not limited to just the container ecosystem. You can use Sixstore to sign a lot of different digital artifacts that are not containers or images. Now, we might be using containers a lot, doesn't mean the whole world is. So the reason I like Sixstore is because it allows engineers or anybody to automate signing into any kind of software build process. The end product does not have to necessarily be a container. Whereas in the case of Docker Notary, you're very limited to Docker-based containers.
Yes, so only like the Docker and our ecosystem of cloud native is more concerned about the SBOMs, right? Like you do not ship SBOMs or you do not ship your signatures when you're uploading a pip package or a Maven package. So how do we as a community take this ahead? Because Sixstore does a great job because I've been working with Sixstore and Persia as well, which are projects of OpenSSF. But you know, it is the central repositories which have to help us with this. So how do we go about this in
Right,
this
so
world?
there isn't enough, I would say, maturity or demand yet for every company to implement signatures, which is what I was trying to allude to. You can do signatures for your organization using Sixstore as a private sort of repo of your organization's signatures, and there isn't enough demand for that yet. But does that mean that it won't be in future? I'm invested in it with the hope that these things pick up and people start to talk about it and a lot of people start to demand it. Hopefully things change in that direction and we see some needles stick that way.
To start all off, I think all of us should sign our Git commits first. I think one day we'll get there.
Hopefully. Thank you everyone once again. Thank you organizers for having me.